Don Ruba, AC/DC final project. We got a band reject filter circuit. So what happens is we have our function generator hooked up to a 1K resistor, and then our load will be a 100 millihenry inductor, and then we have a 1 picofarad capacitor. Now this is what our frequency response graph should look like, showing that the output voltage, once it gets down to resonant frequency, it will block the lows, go back up. And these are our calculations.
I'm calculating resonant frequency. That's 1 over 2 pi times the square root of your inductance times capacitance. So I have 100 millihenries, and that converts to 0.1 henries. And I have 0.01 microfarads, and that converts to it's 1 to the negative 8 farads. And I calculated that to about 5,033 hertz. So that's around 5,000 hertz.
And then what we measured, once we hooked it up to the oscilloscope that is calibrated, we measured at resonant frequency around 6,700 hertz. It's right when it changes. At resonant frequency, our volts per division is at 5, and it's only going up 1 box. So that means that our peak voltage at resonant frequency is around 5 volts.
I had a second calculation. I want to calculate impedance. In order to do that, I have to calculate my inductance and capacitance. At resonant frequency, inductance and capacitance are supposed to be equal. So I have, for my inductance, I have 2 pi times my frequency, which is 5,033, times my inductance, which is 0.1 henry, and then that equals 3,162 ohms. And then for my capacitance, I have, that's the inverse of inductance. So I have 1 over 2 pi times my frequency times my capacitance. So that should be 1 to 3,162 ohms as well, so that's equal a resonant frequency. And then to find impedance, now that I have those values, I can find that. That's my resistor value, which I used a 1K ohm resistor. So I have my resistor value squared plus I have my x of L minus x of C, and that's squared, so that's just 1,000 ohms.
Okay, so for on our schematic, we have a 1K resistor going to a 100 millihenry inductor, and then a 1 picofarad capacitor. Correction, that is a 0.01 microfarad capacitor. So how we have this set up is we have our resistor hooked up to the positive lead of our function generator, and then we have the positive lead on 1 times hooked up to our scope, and then they both share the same ground. So the function generator puts a selected frequency through your resistor and goes through the whole circuit, and then the scope is able to read the sine wave depending on what frequency you are at. That is our circuit. Thanks for watching.